Welcome to 2018 question A-1. So this is an axonometric projection question. So 3D graphic shows a bike shelter. The drawing shows an incomplete diametric projection, so diametric, two different angles here and here, or two similar angles here and here, of a similar shelter using axonometric axis method. The horizontal plane is also included, so here's a horizontal plane. Complete the axonometric projection of the bike shelter. So I'm going to need these sliding set squares here in order to complete that. And we're going to, I'll start off first of all with the overall shelter set of my sliding set squares. So running parallel here to my z-axis, okay, project back all of these points for the main body, and that's projecting back. Okay, then parallel to my z-axis, project back as well onto this surface. So we've got our base. Is that going to be a heavy line? Looking at the object, that probably actually won't be a heavy line. And we've got our back edge there, and mid rail, and that back and the top. So it goes to there. So I'm going to draw in the points that should be heavy. So there to there, that's the front edge. Okay, and just something for yourself, parallel to there. Okay, because they're parallel lines, they're two parallel in all of these. Okay, then we've got to the back edge. And here is the back edge there. And front edge. And sloping surface. Parallel again to there. Right, and we also found that coming back. So that mid rail that we're looking for, we found that coming back there. I could actually project here back, which I will do, but you could also just run a parallel line because it's going to be parallel to your z-axis, or to the front edge there. So. Okay, so that's the outline of the overall structure, and now we need the actual bike rack positions. So run parallel to my z-axis again, project back some of those points straight, and given to us front edge, base edge, given to us, and there. Okay, and parallel to my z-axis. Okay, so they're not giving us the exact position there of the height for the difference there, so I'll just project back onto this line. Up with there, great. Okay, and front edge, projecting onto there. There's a few bits in this, kind of finicky enough. Okay, what we're going to do then is I'm going to find that height and step it off on my, on my elevation. So that's the end elevation, this is the elevation, so let's share using common. So I'm going to slide this back again. Follow that line up to here. Okay, so that is going to give me one bike rack space. Okay, once I've found one bike rack space, the height there, stepped off there, so I can actually do one of two things. I can go parallel to that, because parallel lines do appear parallel in all views, but just kind of be extra careful with it. I'm going to find those points on here. So set up my XY one, or X-axis. It's probably a longer version of doing it, but no harm in doing it correct. Okay, so parallel lines, you can see that these are all parallel. Okay, and see that these will all be parallel as well. And I have the base. Just to make them off. Okay, so that is the completed axonometric of the bike shelter. Alright, bit finicky, a few little bits in it, but very doable. Okay, if you can just get it done at a time. Then part B, we want a line joining from Y to B represents a straight line of the football and the impact of the ball on the glass roof. Okay, so we want to go from Y to B, okay, and this is the point at which it's going to impact the roof. Okay, B is here in my axonometric, so that's the same flight path of the ball. Alright, so I can just simply slide and set squares, find that, slide back, project that forward onto, so just highlight that there, project it forward onto there. Okay, and if you wanted to find it in the main view, you could project B onto that path, draw your line Y, and project onto line Y. Okay, so that is part B of that axonometric question. Nice little handy one to do, provided you did it kind of quickly and were efficient with your time.